Here we are in section 8.2, page 505. This is number 34, reporting cheating. What proportion of students are willing to report cheating by other students? A student project put this question to an SRS of 172 undergraduates at a large university. You witnessed 2 students cheating on a quiz. Do you go to the professor? Only 19 answered yes. So our first part of this question is to identify the population and parameter of interest. Whenever you're identifying the population, think of who are you trying to infer upon. And then for your parameter of interest, it's what unit of measure are you going to use to identify what you're working with. What unit of measure are we using to make that inference? So here we said that what proportion of students are willing to report cheating by other students? So we know that we're going to be looking at students, but then we're going to look at who it was actually done on. A student project put this question to an SRS of 172 undergraduates at a large university. So because it was only done at one particular university, that is the only university we'll actually be able to infer upon. In order to say it applies to all universities, we would have to do the same type of thing at multiple universities. So our population is the undergraduates at a large university. The parameter is the proportion of all undergraduates who would be willing to report cheating. Then in part B, it says to check the conditions for constructing a confidence interval for the parameter. You hopefully recognize through your reading that your conditions here are exactly the same as the conditions that we just had in chapter 7. So you should be familiar with those 3 conditions that we've been looking at. So the sample was an SRS. We were told that it was an SRS. Remember, the SRS allows us to infer upon the larger population of the entire university. The sample size of 172 is less than 10% of the population of all undergraduates at a large university. Remember, that tells us that they were done independently of one another, so we can use the formulas for standard deviation. And then finally, we're doing n times p hat. Now, this is only a slight difference from last chapter. We're using p hat because we're going to use what we got from our sample because we don't know what our population proportion is. If we knew what the population proportion was, we wouldn't need to go through all of this inference. So that's the only slight difference is instead of using p, we're now using p hat. So 19 is greater than or equal to 10, and n times 1 minus p hat would be 153 because there's 172 total surveyed, and then that's also greater than or equal to 10. Remember, this is now allowing us to say that our distribution is at least approximately normal. So then that leads us to part C. We are going to construct a 99% confidence interval for P. Show your method. So to construct a confidence interval, again, I'm going to go back to the resource packet. You're going to see this over and over again. So we have our statistic plus or minus our critical value times our standard deviation. Now our statistic was p hat. We have what that is. It was a 19 out of the 172. Then plus or minus our critical value comes from the confidence level that we're going to use. So if we're going to do 99% confidence interval, my suggestion to you, the easiest way to do this is to turn to the T table in your resource packet. So it's table B for the T distribution. At the very bottom of this, there is a 99% confidence interval. You're going to use that and look just above it. And it says 2.576. So our confidence level that we use for a 99% confidence interval is 2.576. The critical value that we're using, 2.576 for a 99% confidence interval. And then the last thing was the standard deviation. And again, we need one more. So here, let me write this down so you can keep track of it. We have our p hat plus or minus our 2.576 that we just got for our critical value. And then we're going to multiply that times the standard deviation. And our standard deviation we're also going to get from the resource packet. Because we're dealing with sample proportions, we're doing the square root of p times 1 minus p over n. And we're actually going to use the p hats again on that because that's what we have. Now plugging those values in, and this goes to our conditions being satisfied, we know it's normal. So we have our p hat, which was 0.11. That's what we get from our 19 divided by 172. our 2.576, and then if you plug into this our 19 over 172 and our 172, then you're going to get this value, leaving you with a confidence interval from 0.05 to 0.17. And then finally, we're going to interpret this in context. Anytime you find a confidence interval, you should always interpret that confidence interval. So we are 99% confident that the interval from 0.05 to 0.17 captures a true proportion of all undergraduates at this university who would be willing to report cheating. So again, I'll pull this up. You want to go through the same process every time you're asked to find a confidence interval. So even if this very first question up here just simply said to find a confidence interval, you should identify the population of interest, identify the parameter of interest. This is going to set the stage for everything else that you're doing. You're next going to find your conditions or check your conditions have been met. Once you've established your conditions have been met, you're stating the distribution. So we know it's approximately normal with a mean of 0.11 and a standard deviation using the formula that we got out of the resource packet of 0.024. Write down the formula for the confidence interval, plug into the formula for the confidence interval, then get what your confidence interval is, and finally we interpret in context. So again, this problem broke it down into 4 parts for us, but sometimes it'll be one question that simply says this part right here, and you have to show all 4 steps anyway.